Welcome to Third Angle, where mini remote-controlled tanks deliver emergency medical care. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical, and we meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Whether caught up in the midst of a natural disaster or trapped in a hazardous location, some medical emergencies are a danger not only to the patient, but to the medics who are called on to save them. So what if you could send a robot medic in to scout out the dangers before a human ever steps foot on the scene? One which can deliver first-line medical care, check vitals, and even deliver medicine. Now that would be game-changing. Well, let me introduce you to MediTel, a first-of-a-kind product with the potential to save lives, developed by the University of Sheffield Advanced Manufacturing Research Centre. We sent our producer, Alistair, to meet David King, Head of Digital Design at the AMRC, where he test drove MediTel in a sensory VR simulation.
So you've got essentially two VR controllers, left and right, and the controls are essentially like a tank control. Then you've got the VR headset, so that's giving you the view essentially from the 360 camera. And you're driving around a forest.
And I can actually hear the grass under my wheels.
So this is the Digital Design Lab. So this is where we effectively built and prototyped MediTel. So we look at a whole range of different technologies in here, everything from electronics to software design to robotics, and do a lot of work in kind of immersive technologies. So looking at how we can use augmented reality, virtual reality to improve design processes and improve kind of interfaces to systems. And yeah, this is kind of where it was built, where we kind of put it together. The project was an extremely challenging project. It was 9 months start to end. We applied and won into a defence competition. So DASA, the Defence and Security Accelerator, it was a project that was sponsored by DSTL and NDA, Nuclear Decommissioning Authority. They wanted people to prototype technologies for telexistence, so telepresence as well is another way of describing it. So it's essentially where you have a remote operator, in this case with a VR headset, controlling a robotic autonomous system, and to kind of give that immersive presence to the remote operator, so they essentially feel as if they are at that location. So we developed all aspects of it, the operator interface, the robotic system, and the use case we were looking at was around trying to triage casualties in a hostile environment. Could be chemical, could be biological, but essentially where you've got situations where you have casualties and it's dangerous to send in medics. Things like earthquakes potentially, so where you've got humanitarian disasters. It could be something like a terrorist incident where there could potentially be explosives still in the environment, and in those situations they wanted to be able to send in systems like this, robotic systems, where they could go in and kind of start to perform a basic triage on the casualties while making sure that the medics are kind of in a safe zone away from the dangerous area. And that was the brief, and we were given certain triage tasks that we had to complete. So we had to take the temperature, we kind of had to be able to remotely communicate with the patient. We had to apply a painkiller, take a pulse, and also kind of do a palpation. So essentially remotely feel the abdomen of the casualty for any kind of objects that might be there. We kind of put all this together with a number of different sensors and camera systems, and ultimately at the end of the project we demonstrated this to various stakeholders in defence, from MOD to DSTL to a whole range of people, and it's been really well received. The AMRC as a whole was formed just over 20 years ago, and it was really very much focused on improving manufacturing techniques for aerospace. So Boeing were one of kind of the early partners, And it's progressed significantly from there, looking at really the whole manufacturing process. Over a number of years now, very much focused on digital technologies associated with manufacturing. So Industry 4 is a bit of a buzzword that's thrown around quite a lot, and it's really all the technologies associated with that. So it's, robotics, future manufacturing techniques. So we would kind of work with partners to prototype and develop those technologies. So you can see, the whole range of work that we look at. So we work on everything from aerospace to medical projects to space projects and defence projects. We've got an example here of a CubeSat launcher prototype. So we have various kind of medical tools, if you like, so standard medical devices that the robot can actually go in an automatic fashion pick up. And in this case we've got a standard kind of auto injector. So this is the kind of thing you would press onto your leg. We've got kind of an off-the-shelf infrared thermometer. We have a blood pressure cuff as well, which we can put on there. But there are actually some tools that we had to develop ourselves. So in terms of kind of remotely performing an examination of the casualty's abdomen, that's not an off-the-shelf kind of piece of kit. So we actually developed something called a tac tip. And it was a tactile sensor that would feed information back through to the operator. So they would be able to identify if there were any unknown objects, unexpected objects kind of in the casualty's abdomen.
Such as
Shrapnel or that kind of thing, yeah. So this, you can see there's kind of a soft rubber tip. And as that kind of deforms over a surface, you can start to build up an impression, a remote impression of the surface itself. And that was kind of our feedback mechanism, and allowed us to identify any obstructions or unexpected objects on the casualty. All the communication is via very, very high bandwidth millimetre wave communication, so it's similar technologies to 5G. So everything is being passed through that link. That's the control system for the robot itself. We've got a number of different camera systems on there. Sat on the top of the UGV itself, we've got a 360 camera. So we stream that through into the virtual reality headset. So effectively it feels, for intents and purposes, as if the operator is effectively sat on top of the UGV itself. They can move their head around and their view moves around with them. And
it goes with wheels and
yeah,
like a little tank. Doesn't fly. I imagined it flying for some reason, like a drone.
It's it's quite a heavy thing. It's probably around 400 kilos. So we partnered with a company that provided a tracked platform. So that was our base for the unit.
And it's a bit like a mini tank.
Essentially, yeah. It's a very, very rugged platform. The tracked vehicle was essentially developed for kind of agriculture purposes. In itself, as it came, it was, if you like, a remote control tracked vehicle. And there wasn't, we've had to build out all the intelligence and the sensors and everything on top of that. But yeah, we started with something which was really fit for the environment. This thing is designed for, as I say, going around our farms and, pretty rugged terrain. We have won further funding. At the minute, that's quite focused on the operator interface side. So we're actually looking at new sensor technologies to kind of monitor the user in terms of how fatigued are they getting. One thing to consider with these things is, people wear VR headsets, but they can be quite short term. They can be 30 minutes, an hour. Some of these missions could be, multiple hours. They could be 6, 7, 8 hours. And there's kind of work there to understand, so how do we do that? How do we enable operators to work for really extended periods within these kind of immersive environments? There's, people still experience motion sickness and things like that. It's also kind of the environment that these things will be working in. So it's designed for, emergency situations. So they can be quite intense, stressful environments. You've got potentially multiple casualties that you're trying to go out, triage and assess. And it's, kind of doing that over a long period can be quite intense, really. The brief we were given that it would actually be a remote medic, so they would be medically trained. In terms of what it could be, it could actually be multiple operators. It could be an operator that, if you like, got the robot platform to where it needs to be, but then they hand over to a medic to actually perform a triage. So then you kind of, you're kind of utilising the medic for what they're good at, the medical procedures. Yeah. The NHS has specific teams for kind of large-scale mass casualty incidents. So they have specific teams for that, and they would be an obvious kind of user, if you like, of this system. So if a large incident was declared, they would contact this team, a bit like the SEAL team, that kind of thing. So they would kind of arrive on the scene and assess, and they have specialist equipment to deal with these situations. This MediTel would kind of be a potential piece of their equipment that, one of their tools, if you like, that they had, that they could deploy in these situations. I mean, these systems would typically be, this would be part of a larger system. In terms of practically implementing it, we kind of suspect you would have kind of a companion drone system. So this would arrive at a scene in a medical emergency of some description. The drone would go out and kind of survey the area, identify casualties, and then while the drone's doing that, this system is starting to kind of travel to the casualties and then start to triage them. It's kind of the first step of what we think is a much larger system. So we have been told by the MOD that this was the first time that they'd seen a system like this as a fully integrated system. They've seen elements of this, they've seen standalone robotic systems and mobile platforms, but this was the first time really that they'd seen everything brought together into a platform that was effectively suitable for the environment that it was being asked to work in. So we're kind of hopeful that within the next 1 to 2 years that we could potentially deploy this system, and ultimately we would be looking to save lives. That's kind of what we want to do with the system, what it's capable of, and really, it's realistic, I think, within 1 to 2 years that would be a reality.
That was David King. Now here we have a great example of how the AMRC, a world leader in manufacturing excellence, has used the power of Creo to bring life-saving RoboDoctor technology closer to market. They use Creo's integrated simulation capabilities to validate the design to ensure the product was ready for manufacturing, all within a matter of weeks. It's time to meet our expert, Brian Thompson, who heads up PTC's CAD division. Brian, we've spoken about Creo on previous episodes, but can you give us a summary of the importance of validation during the design process?
Yeah, sure. It's not surprising to see a process like this with a product like that putting a strong emphasis on design validation during the design process. It's a very, very complicated product, building a robot for this kind of application. And you can just imagine, with the kinds of mechanical requirements for a robot that's got to be out in the field helping save lives, there's quite a bit of work to be done to test and validate that the design meets the engineering requirements that have been developed. And there's no better time to do that work than early and often during the design process. And that's exactly why we have simulation technology integrated into Creo. We want design engineers to get that feedback as early as is practical as part of the design process. And, given the complexity of building a robot for this kind of application, we think it's a great way to accelerate time to market. And all this will do is when you finally get to the point of doing field testing for something as big and complicated as a robot for this kind of scenario, it gives you a lot of confidence that the product will actually meet the requirements that were set out when you finally have to do practical field testing. Simulation is not a replacement for that, but simulation is a way to gain great confidence in the design and to really minimize the amount of time you have to go back out into the field to retest and revalidate if you fail a test. So this is why customers do it. It's particularly relevant for this kind of application, and I'm glad they were able to take advantage of our integrated capabilities.
Thanks to Brian and to David for giving us a glimpse into MediTel's incredible life-saving capabilities. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, sound design and editing by Ollie Guillou, recording by Alasdair McGregor, and music by Rowan Bishop.